All right, so we can use the measure angle dialog box, which we can go to by analysis, measure angle, to query the angle of rotation, and then we can select so the easiest way to do that is we can see we have two lines, the center line of the original tire and the center line of the rotated tire. So if we just select from one to the other, it should give us that angle. Might even be able to do the other way around to get it. And there's another one there. So that's 23.4 degrees, or about 24 degrees. And that's what so that's where we can see where the interference is, and we can get a number. This is the angle at which we hit interference. All right, so that's the second of three. And if we close these, it says to close without saving, and then just reopen the parts. So once again, we will start a motion simulation, and we will open up motion 2. And it says if we wanted to, we can go preferences, motion, name display. And that'll take off the names. Okay, so the third one, we're going to do a little bit of measuring, which is real similar to the second part. So we open the project. It wants us to put this on static wireframe. And the scenario 1 simulation activated. Oh, there's a typo here. On page, whatever page we're on, if it says double click on scenario 1 to activate it, it's motion 2. And since you've already done that twice, it should be pretty easy to catch that. All right, so we want to measure the angle. So from this same toolbar here, now we've done trace, we've done interference, we're going to do the measure. So the type, we want to do an angle, and it says the threshold box we want to be entered at 1, and this value represents the clearance, and we want to make sure it is less than, and the tolerance is 0.01. And make sure the stop on event and make active are selected. So we want to measure the angle between the lower control arm to the base of the steering rod on the knuckle. So first, let's select the dashed line coming out of the knuckle, which is this one here. And for the second, we want to select this line here. It's the control rod. And if we click apply, it should give us, try that again, angle, and we want this to be 1 and 0.1, apply. Oh, where's our measurement? Okay, so now we want to measure the minimum distance. I guess it pops up later. So now we're going to do a minimum distance measurement of hold on, I'm going to do another measure. So measure minimum distance. And the threshold it wants us to make one of 0.01, and measure condition less than, tolerance is 0.01. Make sure these are both checked, and it selects the objects we want to measure. So we're going to check the minimum distance between the lower control arm to the base of the steering rod ball of the knuckle. So if we select the knuckle solid body, which is this guy here. In fact, let's just select a solid body. And for the second object, we want to select the lower control arm. And if we click OK, it made that. So now we have these two measurements. And if we create and solve the articulation, so let's make another right-click, new solution, articulation, solve with OK. And packaging options, now we can select measure, and we want to stop with when the small cylinder gets within 0.01 millimeters of the lower control arm, which is what we set up. So, and make sure we have stop on event checked, and it says accept the default value for stop event tolerance. We want to make sure we select joint 008, which is this one that'll make this wheel turn, and it says to enter a step size of 10 and enter 6 steps in this box. So as far as these go, step size and number of steps, those you can just have to play around with depending on the size of your part and everything when you do it on your own. So those you can just keep guessing at until you find right. Or if you know you can make an educated guess and everything. So now it wants us to step forward, and we can see these measurements are changing. Okay, so the measured distance threshold has been exceeded. So here it shows the measurements that we have, and as we step forward that solution, it'll show where it stops at, because it stopped on once it got to that certain measurement we were looking for. So it says the displacement column. Yeah. And then so here, the displacement, it shows 46.95, which is the displacement of this in the X direction, I believe, or the Y direction going this way. So this is not, once again, this is not the angular value, but this is the distance traveled by J008, which is a slider joint. So we're going to calculate the angular value in the next step. So now, once we've ran this, we can now say list measurements, and it will pop up a menu or an information that shows the angle that we've measured. So these two different measurements. The first one was the angle, right? This guy here, and the second one was the movement. So we can see after each step what the angle is, and where it started at and where it ended at. And so to see how far this traveled, it says if you subtract the last one from the first one, so 63.3 minus 44. There's this 44.7. This one, we can see that it's pivoted. They only pivot 19 degrees. The difference between those two is 19. So they pivot 19 degrees before there's interference. So that way you can know how far that thing can pivot. All right, so we're going to close this information window, and the last thing we're going to do is the articulation measure area. We're going to click measure angle, and it says measure angle. Click the select object line under the first reference, and we want to select the dashed line coming out of the knuckle. So that is this guy here. And for the second object, select the dashed line in the lower control arm, which is this guy. And there it showed us right now exactly what it is currently. And so you can perform angle and distance measurements with this method within any articulation or an animation task at any point in the pause simulation. So if you want to stop your simulation, your articulation at some point and see what the angle is at that moment, that's how you do it. So that is the tutorial. It's pretty simple. Once you've done this, you can just do what Larissa showed, how you should be able to do it here. Okay, and back. Okay, so now we have a solution. We should be able to export this as an MPEG, 17 frames, and let's see here. Let's try that. Okay. Okay. Oh, that was quick. So, I don't know if you guys saw that, but it does move. It shows the very short video. So if you say what? Oh, very good point. Back. media